Top of the morning, everyone. I'm in super high spirits. We're gonna make something super fun today. I'm going to try to make a holder for this micrometer, and I've come up with the simplest hook possible for the French cleat wall system. And I'm gonna tie myself because I think this will go from design to finished product very, very quickly. And this is kind of an example for all of you who are thinking about helping me with this project. I want to have this on the wall in 20 minutes or less. Let's go. We need to know this measurement. You can take it from the image. I think 17.5 is the safe bet. That's basically all we need to know. Micrometer holder. We wasted 1.5 minutes creating the document. So we know the hook should be 22 millimeters. Boom, boom. This is vertical to this. The front side, I think, is 10. Wasting time on filming as well. And then how high should it hang down? And here's the beauty. It doesn't have to hang down far. 40, 50 for good measure. These lines are parallel. This is 22, 45. Everything is constrained. The profile is done. We're going to extrude it 17.5, the first measurement we took. I'm going to fillet everything. Fillet should be in a sketch. On these corners, I want it like small. You can just grab and just point. Boom. For 3D printing, I love to fillet all the edges round like this. Boom, boom, boom. So the hook is completed at 5 minutes 30. We're going to export this, go into the slicer, auto place it, done. Wall loops 2. Should we do 3 to make it a bit stronger? Boom. Yeah, we're losing a lot of time on the printer preparing itself. It hasn't even started with the first layer yet. We have the first layer at 14 minutes. So I'm gonna note down what the different steps took. Printer preparing 5 minutes. This is about the simplest print you can imagine lying on its side like this. We're at the final layer here. That's it. Okay, no chill here. Wash my hands. From the printer, it's on the cleat system, and there we go. 2340. I really love this simplicity. This is a fail-safe print. And if you want to put it somewhere else, you move it somewhere else. So here's a time rundown. I spent 8 minutes of doing manual labor and 16 minutes of printing. And during these 16 minutes, I could have designed more holders. So there's one interesting design change we could make. I made this hanging distance pretty low, which adds a lot of printing time. Let's just print a short one to see how well that hangs on the cleat wall, which could be interesting for all of you who are going to make holders, because that would also reduce plastic and print time. Let's try. We're gonna change only this height constraint. Let's print this. This is the final layer on this one. Here's our tiny version. Yeah, I do like it a bit less because it's more beautiful with hanging over the cleat, but it could tip over. I think the design principle is to get the weight below this point, below this line. And as you can see on this one, it's above, which makes it a bit more unstable, which is unnecessary. I think too long is better than too short. Success. Now let's make something a bit more trickier. I'm going to make a holder for this saw, and I'm going to pretend that I don't have the saw in my hands. I'm only going to use the image as a reference material because that's how the situation is going to be for all of you. Let's clock this holder. All right, we're gonna learn how to take measurements from an image. We need to start to make a sketch. On this sketch, we're going to insert an image, uploading the image and choosing it. And now I'm going to draw an image rectangle from the origin point. The first step is to rotate the image, and I want this ruler to be straight. So I'm going to draw a reference line that I'm making horizontal. I'm using transform on this image to pivot it around this point. Rotating images in Onshape is actually not that easy. Fusion does it better. Let me show you. When you edit canvas, you can rotate the image and you get a perfect preview, which makes it easier to align your image. Let's actually do a workaround for Onshape. All right, so I'm in Pixelmator, where it's easier to rotate an image. So I'm putting the ruler, which is my reference point, all the way up to the edge. That looks spot on. I'm cropping this and saving this as a new file. Back in Onshape, I choose my rotated saw, and this works much better. So Onshape has some work to do on this part if I'm not missing the functionality. And here's the magic. Now, to know that this ruler is the correct size, you press L to make a sketch line. And I start right here at the 15mm line. Boom. And then I go over to 35mm. Just something that is easy to count. Boom. And then I say that this is 200mm. So you see now Onshape thinks this is about 68. But when I put 200 here, Onshape will auto-size the image for you. The image is calibrated, and to avoid it going around, we can fix all the lines. Now I can't move the image, and we can start tracing it. Is there lens distortion? Yes. Are the measurements perfect? No, but they're really good enough to make a simple tool hanger. So I want my hanger to start here, and then I want it to have a nice curve there and here. I'm happy with this trace. So now we're gonna make 2 planes on the side of this trace. So we finish this sketch, make a plane on this line. It's going to be a line angle at 90 degrees. I'll make a sketch on this new plane, and I use this little point from the line. And now we have to make our profile. And now I want some kind of U shape like this to hold the saw. To know how to make the U shape, I import this second image here. This I'm going to make very simple. I'm just going to take some measurements here without putting it in like perfect position. I go from 100 to 200, and I say that this line is 100. And now I can make some measurements. So I can see that the thickest is kind of 29 here by just drawing a line. If you make it 30 wide, we rather want to make it too big than too small. It doesn't have to fit perfectly. 32 is a beautiful number. So that's all I need that image for. So we're just gonna hide this for now. So I know that the inner wall should be 32mm. And then I'll constrain everything nicely. I don't care about the radius. I'm just gonna make it round. I'm constraining the U shape to that point that we referenced earlier. Now I wanna know how high to make this front wall of the holder, and we can decide that here in sketch 1. So say we want the holder to cover half of the handle here. Looks like 20mm is a good choice. So this height should be 20. And the holder thickness here, 4mm perhaps? Hang on, that depends on print direction. Oh, we're gonna print this on the side. Ha, we're golden. Kids, here's a trick for you. Don't leave these corners like this when you're gonna 3D print something. Go up here into the sketch fillet and just add a little beautiful fillet. Boom. Doesn't have to be harder than that. Then you don't have to fill your designs afterwards. Okay. You know what? This holder is ready, and we're going to sweep this. Using the sweep command, we choose the profile, we choose our sweep path, which is the traced line that we did before. Et voila. A beautiful saw holder. I was hoping for this to kind of end vertically. Oh, okay. Keep profile orientation. Then it ends straight. Yeah, I think it's more beautiful straight. And here we can get a feeling for how it's gonna hang. Is it going to be easy to get a saw in? It's not, right? Because here this opening is not. Here we really gotta think, because we really gotta measure this opening, and lucky us, we can. In this sketch we can measure this opening here. I see that it is 25mm, which tells me this height of the U profile is too high. So we should actually go down, and let's see how that feels on the saw. That should be no problem getting the saw on and off. This was my first time using an image here in Onshape. So now all that remaining is to add the hook. 22, the standard measurement for our hook. And as I said, don't leave these sharp corners. Go ahead and put a bit of a fillet in. It makes everyone happy. Final step, extrude the top to this face Ah, we have an issue there. Wait, there's a remove face feature in Onshape. You see what happened right here? I think there's a remove. I saw it in some tutorial. Delete face. Haha, did you see that? That is actually fantastic Onshape feature. Let me show you that one again. So you have some annoying thing sticking out like this, and you click that face, and Onshape's like, I'll fix that geometry for you. Fantastic. And this holder can be printed like this. Okay, 20 minutes to design it, solving a lot of problems. Oh, we're actually not done though. Someone gave me this trick to always fillet for 3D printing, and it is a really good trick. I'm gonna do a super generous 2mm fillet on all the edges here. That just makes a really nice look. We're in the slicer. I'm gonna auto place it, and it puts it automatically on my preferred print direction, which is a good sign. 2 wall loops, 2 bottom shells, and 5% infill. An extremely simple print in a perfect print direction. Let's print this. All right, our handle is printed. That print quality is just sublime. Wow. I haven't taken any physical images of the saw. I've only used the image. So let's see how we did here on the wall. So first of all, let's see the holder. That sits perfectly on the wall. Moment of truth. That's perfect. I love that it looks so straight. I can take it and I can move it there. I'm happy. I did a good job on this. I actually did a good job on this. You can't like make a simpler design than this, and it does the job perfectly. Wait, am I finding out one issue with this holder? It's hard to grab the saw in the handle. It's like you're gonna grab it in the blade, but you actually want to grab it. Perhaps it should just be in 2 hooks on the sides, so you can grab it straight off. But this kind of printed hook is a fantastic proof of concept. So for everyone helping me out with this project, I encourage you to do a lot of these simple hooks like this. But let's take this one to the next level. Let's improve the ergonomics of this holder. First of all, we want it longer on both sides, which we should be able to do in this sketch. That change already made it longer, and now I want to remove some material in the middle here. Press N to look at it from the top. Let's use this line and this line. So we can think of the print direction when choosing how to make this cutout. Because if we print it on the right side, we can make this right line much steeper and to get the hole faster, so to speak. Let's put an angle on this. 100? Yes. So that's steep. And then here on the left side, that's where the printer needs to build up the print. So that angle, it's nice if it's only like 45. Now I'm using this profile that we made to make a remove extrusion. Boom. And here you can see my idea. I didn't make this even. That's because we want to print it in this direction. And that makes it easier for the printer to make that hole. We should make the hole for my fingers much larger. So I'm going to reduce this 12 to 6 on both sides. I'm happy with this, and then I'm filleting these 2 edges with just a 1mm fillet because we like that. And let's print this. Ergonomic saw holder is printed, and it looks to be another beautiful print. Like, check this quality. And the design looks so architectural, despite the fact that it's just a single tool holder printed from a very simple print direction. I think I actually designed something good. Let's try it on the wall. It was awkward on the first one that you couldn't grab the handle. So here's the second one. We hang it our cleat system just like that. And all right. Oh my God, yes. Oh my God, yes. That's such a good idea for all of the holders to not abstract where you want to grab the tool. And again, I think like a huge success. Look how floating it is. I think it's beautiful. So that's good inspiration for everyone making tool holders. Simple one print, perfect holder. This is my Sandviken Stradivarius musical saw. And I think I'm lucking out on this one because I think we can use the discarded holder for that saw. And it hangs really nicely straight down. And I think this is an important design aspect also, what like saws next to each other should hang at the same level. So I made all these images and posted them onto the engineering server in the hope that someone will want to make holders for these. Let's see if it's actually going to happen. So far, we have two types of holders. This is the printed upside down holder in one piece. This one is the same principle, it's printed upside down. And then we have these hook holders as a second category, which is really nice and super simple, printed on its side. This is also the hook holder, super nice. But I'm going to make a version of the hook holder that I want to discuss for my power drill. And this thing is a little bit bigger and a little bit larger, and I have a fun idea for how to do this. And we start as always by scaling the image. This is 200 millimeters. This design is going to have one hook here and one hook here. I'm just going to constrain these lines by fixing them. It's a bit beginnerish, but it's also pretty efficient. So here I'm checking the width, and I have the width on both hooks. So I'm using this line as a line for a new plane. I'm putting a new sketch on this very plane. I'm using the start of the path there. All right, we have the hook profile, and we're going to sweep that profile along this path that we made previously. Boom, boom, boom. Then we're doing the same for the front hook. We're attaching a plane to this line here. Line angle, perfect. We made a completely unconstrained shape, and then we start to get it in order by constraining it. Same story here. We have the profile. We're gonna sweep it along this path. And it doesn't want to, but then we choose keep profile direction, orientation, and it wants to. Are we going a bit high on the front? This will never fall off. So let's actually reduce this 20. And on the first one, we do 20 as well. Just revealing the power drill a bit more, saving some material, saving some printing time. Now I'm going to make the French cleat hook. These are our standard measurements, so no guesswork here. Just the dimension. This is 22. This is 45. This is chunkier. Let's do 12. Let's do vertical. Let's do parallel. Thinking this 18 is overblown now when I see it. 12 is fine. Sketch fillets everywhere to not anger the fillet gods. Simple extrusion. And now we choose up to face. And we take the other side. And boom, we have our first simple hook. We got our two hooks. You can kind of see how the drill will hang. But I forgot the idea with my design. So we're going to print these hooks separately, but we're going to make a distance bar to keep them together on the correct distance. So let's go to this sketch. We're going to make a puzzle piece here. All right, here you can see the two puzzle pieces on the top, which we're gonna use to connect them. So now let's make the third part that will connect these two. We have these profiles, simplest ever, extruding this all the way over here. And it's a new part. Boom, boom, boom. I have no tolerance between these parts, which means we're gonna have a very snug pressure fit. We want one more extrusion. These are going to go from to there. And then we're going to have a starting offset from there. And then we're going to add this, but the merge scope is only going to be this one. Boom. I'm proud of this design. All these parts are trivial to print. I think it's going to be a fantastic holder with really not using a lot of filament, actually. Let's go ahead and give most lines a 1mm fillet. Especially the entry lines to this pressure fit is really nice. If you fillets absolutely everywhere. I'm gonna leave this edge untouched just for a bit of extra bite in the pressure fit. And my friends, we're done. I really like using the images that you can kind of see how it's going to be even though the image is 2D. Looking at this from the front now, I want the drill to hide this part. And I really think we can do that. I think this is the culprit. Yeah, much better. Only renaming the parts. Right side drill, left side drill, distance. Let's print. So here's the print direction for this holder. As you can see, no support. Layer direction is in the correct directions and really easy to manage in really every sense. Going to be exciting to try this first one. The holder for the power drill is ready in the printer. Let's go and get it out. 3 simple pieces, no support. Pressing that press fit, perfect. Pressing this press fit, perfect. Big moment of truth here. Holder, boom, French cleat, and perfect! Yes. Really nice. Huge thank you to everyone who have already designed some holders. I'm home taking care of my newborn, but I'm soon back to review all the designs and print and hang them on the wall. So thank you so much for designing and good luck. Hope this video helped. See you soon. Ciao.